Now here we move ahead with the corner point method. Now here the first step is we have to plot the feasible region, right? I have written here the formulated LPP that we did earlier. So we have to maximize the objective function z subject to the constraints given here, right? Now to begin with, we have to plot all the constraint lines one by one, and we are familiar how to do that. Let's consider the first line, for which we consider 6x plus 4y equal to 120 first. So by considering the equality, we will divide both sides by 120 and we will get x upon 20 plus y upon 30 equal to 1. And we know how to plot this line because 20 is the x-intercept and 30 is the y-intercept. So we go ahead and plot that particular line on the graph, so it looks like this. Right? That's the first constraint. Then we go to the second constraint. So here again, considering the equality, we divide both sides by 180. So we will get x upon 60 plus y upon 18 is equal to 1. So therefore 60 is the x coordinate or the x intercept and 18 is the y intercept for this particular line. So we are plotting the second line also. Now we have to also mark off the arrows based on the inequality. Now both of the inequalities in the first two constraints are of less than type. So we have seen earlier how to mark it considering any general point, and we see which side of the line satisfies the given inequality. Here it is less than type. Then we have to also mark off the non-negativity constraints, that is x greater than or equal to 0 means it will be an entire region to the right side of y-axis, and y greater than 0 means it will be all the region above x-axis, right? Now having done this, we have to shade the feasible region. That means what is the region which is common to all of the regions marked by these arrows? Okay, that's the feasible region. So we go ahead and shade that final feasible region by shaded lines. And now it will look like this blue colored shaded region. That's the region which is common to all the constraints. Now the next step is, if you recollect convex polygon theorem. As per that theorem, we are supposed to check the values of the objective function only at the corner points of the feasible region. So therefore here, as we can see, it's a convex polygon, and therefore we have to consider the 4 corners or 4 vertices of this particular feasible region, out of which one is the origin. We know it is 0, 0. The second point is 20, 0. Then this particular point is 0, 18. If you see, we had used it while plotting the second constraint. Now there is fourth corner point whose coordinates we don't know, but we have to find them by solving the equations of the two constraint lines simultaneously, right? So on doing that, we will get the coordinates of that vertex also. So therefore now in the next slide, I am showing all the corner points with their coordinates mentioned. So here they are. We also name those points. So O, A, B and C. As you can see, these are the 4 corner points. Now what we have to do is we have to evaluate the objective function at all of these corner points. So we prepare a kind of table. So as shown here, we have listed down the corner points and we have evaluated the value of z at the corner points one by one. So as an example, when you use the first corner point, since both x and y are 0, obviously the value of z will also be 0. But we complete the table and find out the value of z for the remaining 3 vertices also, and they are as shown here. Alright, so now as you can see, we have got the values of z at all the corner points. Now out of which you will observe that the highest value is 25,500, and that occurs at the vertex B 10, 15. Alright. So now since we had to maximize the value of z. Obviously the point that gives us the maximum value of z is the required optimal solution as per the convex polygon theorem. So therefore the point B is the optimum solution. And what does it mean is, if you recollect, we had assumed x and y as the decision variables in the beginning. X was the number of bicycles and y was the number of tricycles. So that means the final answer of this LPP is that to obtain the maximum possible profit, the manufacturer must manufacture 10 bicycles and 15 tricycles, and the maximum profit that is obtainable from this is 25,500. So this is where the solution of the LPP is completed using corner point method.